Hello and welcome again. My name is Nate McGee and I'm the Technical Director here at sensemetrics. Today we're going to be unboxing the next device in our family of connectivity products, the Strand. This device is a narrowband IoT product, and this particular build I'll be sharing today is capable of supporting vibrating wire, a common interface type for geotechnical and structural sensors. Despite the long list of sensor manufacturers with vibrating wire sensors, the Strand serves as a flexible device that supports the range of products available on the market, regardless of frequency range that they operate, providing a very precise and reliable method for automating these sensors. As a narrowband IoT device, the Strand offers a cost-effective means of automating these lower-cost analog sensors while wirelessly connecting to our broadband IoT device, the Thread, creating a secure wireless network at site that operates with resilience to challenging site conditions. And of course, the Strand, as with the rest of our sensor networks, are cloud connected and can be securely managed on-site or off-site using your browser or mobile phone. For those of you who have experience with automation of sensors using data loggers requiring scripts or extensive configuration, you will be able to appreciate the technical leap offered by the Strand. Engineered to work reliably in challenging environments while remaining easy to use. Not waiting any longer, let's open this thing up and check out what the Strand has to offer. Opening the box, you'll find a few accessories. The batteries, the antenna and the port plugs, and the Strand itself. You'll notice right away the design aesthetic is similar to the Thread but smaller in size and weight. Due to it being a narrowband device, much of the size difference is accounted for its ability to operate off of small interchangeable batteries. You'll also notice that, like the Thread, it is made of a durable UV-resistant ABS material and has a rigid aluminum backplate with a mounting pattern for supporting U-bolts and lag bolts. But the real important stuff is on the inside. As I begin to open the enclosure, you'll notice that I'm using a very specific tool to remove the security fasteners. Loosening these fasteners, you can remove the lid and access the electronics directly. Now that the lid is open, let's review each component. The first thing you'll notice are the battery carriages. These support D-cell batteries, but not just any kind. Due to the wide temperature ranges the devices are exposed to, they require a lithium chemistry, and specifically a model that provides 250 milliamps of max continuous current. Depending on the measurement and communication interval selected, 2D batteries can be expected to operate anywhere from 9 months to 10 years. The next thing I'd like to point out are the sensor interfaces. You'll see here that this device supports 4 channels, or 4 total sensors, and that each channel is conveniently labeled to indicate where each wire lead should connect. As mentioned earlier, there are many manufacturers of vibrating wire sensors, but there isn't an industry standard color scheme or labeling for the leads, so I'd encourage you to consult the operating manual for your particular sensor and confirm which are the positive and negative vibrating wire leads, which are the positive and negative thermistor leads, and which is the shield. It's important that these are connected in the correct polarity. Connecting the sensor, you'll first want to route the VW sensor cable through the corresponding cable gland, first removing the plug, and then using a small flathead screwdriver, press down on the yellow clip to open the mechanism. Then you can slide each lead and release the mechanism to secure the lead. It's critical that you make a good connection here, so pay close attention to the amount of wire that is stripped and that the wires are not frayed. Once the connection is made, give the wire a slight tug to confirm that it is firmly seated. Moving to the next component, you'll see the RF transceiver located here. This particular build model happens to be the sub-gigahertz model used in the North American region, but these can vary slightly based on your location. Based on your region, these transceivers are offered in varying frequencies and power ranges. The product data sheet provides a summary of the expected operating range for each transceiver type, so please consult that to make sure you're selecting the appropriate option for your particular application. Another item you may notice are the 3 buttons located in the center of the board. For the most part, these are reserved for advanced troubleshooting, so there's no need to engage them during normal setup or operation of the device. You can find more details on these buttons in the Quick Start Guide. The last integral piece inside the Strand is the LED found just below the buttons. This LED provides operational cues for the Strand without having to open the software. To review the device's LED behavior, let's install the batteries and boot it up. You'll see that as soon as I install the first battery, the LED turns solid red. This indicates the Strand is in what we call hunt mode. During this initial 60-second period after power is supplied, the Strand seeks to connect with the most optimal Thread device as a gateway. Once the Strand establishes a connection with a gateway, the LED will turn off. It's important to note that if the Strand cannot find a gateway during the initial 60 seconds, it will turn off for 10 seconds and then turn on again for another 60 seconds. It will repeat this cycle until a successful connection is established. The next LED behavior you observe is a solid green light for several seconds. This indicates that the Strand is in measurement mode. During this period, the VW channels as well as the device diagnostic sensors will be collected and stored to the device's memory. A solid blue LED indicates the Strand is in wireless transmit mode and is attempting to securely transfer the stored sensor observations to its assigned gateway. Upon successful transfer of the observations, the Thread will immediately store and forward the observations to the cloud, where you'll have access to the measurements in our browser or mobile app. If the wireless transfer fails for any reason, the Strand will hibernate and attempt to retransmit the observations at the next reporting interval. If you experience issues with consistently failed reporting, the Strand's antenna port, located here, can be connected to a high gain antenna or cabled to an antenna mounted at a more optimal location. The SMA connector also supports direct connection of an antenna like the one supplied. At this point, it will be time to close and secure the Strand and launch our phone app to identify what sensors have been wired to the device and what measurement and reporting intervals you'd like. We'll cover these software-based steps in the next video in our series. If you enjoyed this video, feel free to check out our other tutorial videos. Please subscribe to our YouTube channel or visit the video link provided. See you again soon.